Quadrilaterals. Quad means four, like in a quad bike or quadruplet, so it's four kids that are born at the same time, like triplets, quadrilates, whatever you want to call them. So quad means four. Now, when we have quadrilaterals or quadrilateral shapes, it is four-sided shapes. The first ones that we're quickly looking at are irregular, which means that they don't have anything, it's not a specific shape, it can be any size. The first one is convex, which means all sides is pointing outwards, or all the angles are less than 180. The other one is non-convex, also called concave. I like to say concave because it caves in. It means that one of the sides is actually coming in. So that is 1, 2, 3, 4 sides. One side is coming in. Convex, concave, there is no relation to the sides. All we need to know is that the sum angle of quadrilaterals are 360, and it's easy to see why. If I break this up into two triangles, okay, and I say this side plus this side, this angle plus this angle equals 180, and this angle plus that angle is 180, then all the angles added up together is going to be 360. And it's going to be the same here. If I break this up into two triangles, this angle is 180, this angle is 180, altogether the angles add up to 360. The thing that we're going to use to show that for quadrilaterals is just a simple sum of quadrilaterals. It's just going to be a shape like that, and that means that the sum of quadrilaterals equals 360 degrees. 360 degrees. Okay, so that's the angle sum proved by this. Now, the other thing that we need to know is the special quadrilaterals. Special quadrilaterals. And the easiest way to learn this is to actually draw the sketch properly. And if you have a proper sketch, then you can learn all the other properties. The first thing we're going to look at is a square. And we're going to draw the square. The first one I'll draw simple, and then we'll work from there. And I'll summarize the rest for you. So the square looks like that, which means you can say first of all, you can see that all sides are the same. You can see that all angles are 90 degrees, so you can put that in. What else can you say? There's nothing you can see, but we always have to discuss what's happening with the diagonals. The diagonals are the lines that are going from the opposite side. So if we do this, and then also do this with a ruler, what do we see? We see that the diagonals intersect each other on 90 degrees, and we can also see that the diagonals intersect each other. So by just doing that, you can discuss all of the special triangles. So the first one was a square. The second one, next one is a rectangle. Opposite sides are the same, 90 degrees. Angles, which means they are parallel. We can also see the diagonals are not 90 degrees, but they are all the same size. They are all the same size. So if you do it properly, you'll be able to see this. Next one. Next is a rhombus. Rhombus, all sides are the same. You can see the angles are not 90 degrees, but this angle is the same as that angle. This angle is the same as that angle. We can see that the diagonals are intersecting at 90 degrees. This is the same as that, and that diagonal bisect, so that they bisect each other. Now just quickly, the word bisect you just write it up there. Bisect means, bi means two. Sect is cut, so it cuts it in two. So bisect means cut in same size. So when I say bisect each other, it means that that is the same as that and that is the same as that. Okay, so those are the same and those two are the same. That's what it means if it bisects. Next, parallelogram. Parallelogram, this side's the same as that side, these sides are the same. The opposite angles are the same. They do not intersect each other halfway, but they do bisect each other. So that is the same as that, and this is the same as that. So you can see, you can learn all of these, and then by just drawing with either a mathomat or with a ruler, if you draw them properly, you can get all these characteristics. With a kite, these two sides are the same, these two sides are always the same. This side is the same as that side. These angles are the same. Those angles are not the same. And those sides are not the same, but they do intersect each other at 90 degrees. So you can see how many of these characteristics you can get. The last one is a trapezium, but there's nothing in a trapezium that we can use. The only thing that we can use in a trapezium is that we have two parallel sides, which means these angles are, those two angles are co-interior, and these two sides and these two angles are co-interior. But otherwise, there's no other properties.